Hey guys, and welcome to this video. So today I would like to create a algorithm with you. I want to program a algorithm with you that is going to solve alliterations. So if you don't really know what alliterations are kind of in a sentence. If you find stuff like my mother makes me happy, then you have like my mother makes me. So all of those words start with an M. So that basically is the alliteration that we have to find in a sentence. And we would like to give those alliterations within a sentence we want to give out really easily. So we're not going to make a perfect algorithm in this video. We're going to improve it sometime later. But we are going to at least solve the rough stuff. So first of all, what we are in need of is a project. So I'm going to go to my desktop and I'm going to stagehand. No, I'm going to say pub global activate stagehand. So if you don't have Dart on your machine, you should install it now, and then you should be good to go. So I would say learning this language is really worth it because it's a language by Google and it's fairly new. So Google also has Go, so Go is really, really, really popular these days, but Dart is not really, but it's so much better than JavaScript, I think, especially because it has, for example, it has, well, object-oriented programming delivered, you could say. It brings object-oriented programming with it on its own, what JavaScript, I think, does not have, at least not in a really useful way. Now it has with TypeScript, I know that, but, well, Dart is just nicer to program generally. So what we have now with stagehand is something that it's just basically for scalability. So for scaling, so what we can do now is stagehand, and you will see we get all of those things: console full, simple, server shelf, web Angular, so there's Angular for it, and also simple, which is what we're going to use. Or you could do just a executable if you wanted to, but we're just going to say here stagehand generator name web simple for a new folder that I haven't made yet. So I'm going to call it Alliteration. I'm going to head right into it, and I'm going to create it right here. There you go. Now we have to run pub-get to get all our libraries, and we should be good to go. So basically, Dart has its own virtual machine that runs on browsers such as Chromium, which is basically the backend for Chrome, but there's a special version which is Dartium, and Dartium, which is kind of Latin, right? Well, this is what it allows you to do is actually just run Dart applications right away, instead of what happens in other browsers is it's compiling itself to JavaScript. So it takes a little longer. But Dart itself is really fast, and if you have the virtual machine, it's way faster. Just the really bad thing about this the thing here is sorry, my English is not that great today. So the bad thing about this is that Dart is currently not, the Google team behind Dart is currently not focusing anymore on the virtual machine itself. It's focusing actually on compiling Dart to JavaScript, just because not many people are picking it up right now. So that's kind of sad, but let's get right into it. I'm using Atom for this, and I have installed some language support. Just so you know, my environment also looks a little different compared to what it used to look like. So there you go. I don't know where this code came from. Here. This here is Rust, by the way, and which I have made this algorithm in already, but it's like I'm currently learning Rust, so that will need a while till I'm good in it, because way different. So there you go. We have all our alliteration program, and let's run git init, git add everything, and then let's say commit initially. This is my thing. I know all of the people on GitHub usually originally in Git do initial commit, but that's not really how it should be structured. It should always be like you are kind of telling what to do, and that's commit initially. So that's what we're doing, and we're good. So now we have a main Dart file, which has a query selector, as you can see here. And query selectors are basically what we are in need of for most of the things, but that's what we're focusing on. So you see here you have a type that the function is going to return in main, which is the function's name. You also have like something imported right there. And we're going to create something, a function that returns us something, which is, let's think about this. It's going to take in a text, and it's going to, for example, if I say something like, I'm writing a lot here. Constant is, by the way, is our let in this language. So we're saying constant, which I actually like more. Constant message, for example, this is not going to be changed. Let's say hello. No, let's say, well, my mother makes my breakfast, my sandwich for school. What am I doing here? For school. And there we go. There we go. Did I write this right? I don't really know. Sandwich. I did write it right. Sorry. There you go. I was just really confused for a second. Right. So what is this going to do? Well, in order for us to analyze this fast, we are going to need to split this into single words. So what we're doing here is, let's first declare this a void, but we're in the need of another type to return here. So what we're going to do is we're going to say string to list, which is basically like an array. And the thing here in this language is we also have lower camel casing, as you can see here, for naming this instead of constants that will never change, for which we will, so not like this, but really like, I don't know, units and stuff. And for that, you are going to type it in upper, and like everything should be capitalized and should be using those. Or for example, this here would become a string to a list, like that. All right. And this is going to, well, the language supports this kind of style, but we also have a one-liner style, which is simply this. It looks like a return, and what it allows you to do is code without actually writing return anymore. So you could say here in the parameters, string input. So you see, not input, and then this, and then that, you just do string input. And then you're going to say here, input dot split pattern you need, which is add a space. And it doesn't care, like there's no difference between singular and double quotation marks. And we also need a semicolon at the end of every step. This here needs a name message. So we can try this, print. Sorry, this is not Rust, and it would also be this in Rust, but okay, well, anyways, string to list, we can call this right there, and we are in the need of a return type here, which is a list, and you can say of which type, which is a string type. And so if we type in our message and print out, I hope this works. No, that doesn't work. Okay. Then we can run it right here in Chromium. Nope. And this should be printed out in our console. Here, well, my mother makes my sandwich for school. It's an array, or a list. And it printed really nicely, that's good. So what we have to do right now, and the next step, is to actually analyze this whole thing. So what we're going to do now is say analyze, which is a function, and it's taking in another input, and this is going to be of type a list of strings, and this is not a one-liner anymore, it's going to be much more. And this also is in the need of a return type, which we're going to say is a list, which because it holds all the different alliterations. Let's say there are multiple throughout the sentence, so like here it would stop at my, because here's not an S anymore. And let's say it's like somewhere here there's another alliteration, and we want to have it as two arrays. So we're in the need of a list in the end that is made out of lists, which are of type string. I know this looks a little weird, but that's what it is, and that's what we're going to need of. So what we can say right now is, for the next thing, we want to go through our list here and analyze every single word. We say word in for word in input, right? Well, it doesn't exist here. What we have to do instead is input, and you need the parentheses, and we can say int I is 0. This is a really old school looking C style for loop. While I, basically, I is smaller than input dot length -1, because, well, the length, for example, we have 5 elements, the 5th element is a position 4, so that's why we do that at the last position. And then I++. Then it goes through everything, and that's what we have to do. And then what we do is we need, first of all, a variable. It's a variable, a temporary alliteration, which is a new list of type string. Do you write it like this? I'm not sure right now. Do you write it like this? I think so, I hope, because in Rust it's like, it's a little different. It would be like a vector and a new like this, which is not the same here. Okay, temporary alliteration, and then we're in the need of actually a final alliteration that's going to return at the end, which is final alliterations, which is a new list made out of lists string, like that. And it's going to return at the end. So now we are going through everything, and let's say if temporary alliteration is empty, if that is true, we're just going to say temporary alliteration add, in Rust it's push, or append and swift. Here we're saying the current word, so that would be our actually input dot input at position I. So that would be our current word. Else, if it's not the current, we have to compare the letters of those two guys. So what we're doing here, of like the latest element in our temporary alliteration to the current word. So how do we do that? We say if the current word, that would be input I, so the current word, and that split by no characters, because then we split our word apart, split by nothing, and then we need the first value, which is basically its first letter. If equals to, we're in the need of temporary alliteration. The last value, which is the current one, split, that's a word, because it's a word, split by that, and then the first one. That should be our letter that we have to compare it to. If that's the case, what we want to do is, well, if that is the same thing, we want to say temporary alliteration, add our input I. If it's not the case, if that's not the case, I know you could actually do recursion here, but we're not. So else. So if it's not the case, so what we want to see is this temporary alliteration currently bigger than one element? Because we could also have just one element in there. So if temporary, okay, it makes me type it out. Thank you. Length bigger than 1. If it's bigger, let's say final iterations add. So we put our list into the list made out of lists, and we say that's like our currently temporary alliteration, and then we want to clear it up. But also, if we say else, so if it's not bigger, we will just want to clear it because it's not going to be added. So we just have to say right underneath here, because for both cases that's going to happen. Temporary alliteration, remove range, start to and, where, how do we do that? Let's just make it a new list. Temporaries, like that. There you go. Temporary alliteration. Can you actually just do that? I don't know. I think so. Should be good. Then we replaced it, and we should have our wellies. Let's see if that actually works now. Well, my mother makes my sandwich for school. So if we do that, well, my mother makes my sandwich for school. Okay, well, that doesn't work because here we are in the need of analyze that piece of code. My mother makes my, you see, it works. Sandwich for school, which was no. Even, I don't know what sentence to write. Which was warm when I ate it. Made my sandwich for school, so it makes more sense. My mother made my, which was warm when. So that's true. And we have our alliterations right here, and we printed them out in our console. It doesn't do much yet. But I'm gonna, well, no, let's just do that right now. Okay, so we have our main right here. And what we want to do is, let's say, we have an input here, placeholder, sentence, that was right, and ID, text or message, I don't know, text, let's say text, and value is going to be nothing, sorry. That should be good. Here we have our thing, and we should have a P. Let's see if it works. Yeah, there it is. Because this is by Google, the main font here is Roboto, so that's pretty cool too. All right, so we don't really need that anymore, to be honest. Let's comment it out, and what we're gonna do instead here is, we don't need that either. Let's make it like that. And we have to do query selector. By that, we're selecting selector spy. So we have to say ID, and we know ID is with a hashtag, or just a hash. And we just call it text. And now we can say on, for example, click, or on change. Let's try on change. And then we can say listen. listens to a. You see what it listens to? Event. So on data. So what we need here is a function. So this is going to be a void function, and let's say type action, maybe, or type event. Let's say type event, which is of type event. And here, let's just say for now print hello well, typing like this, and type event. The function is going to go right here. Let's have a look at if this works. Hello world. Okay, no, that does not work. That's sad. So it's another type, probably. But it is of type event, so we know that at least. On key up, on change, on submit focus, ended scroll or size playing, mouse up can play, touch and key press. You might be good with this one. Let's have a look. Hello world. We're typing. That's what we want. So and every time this is typing, what we're going to say here is query selector of type, what was that? Text p. This is going to need an ID. Let's say you can also access it by other values and stuff. They don't need to do ID. You can do other things too. And we could say here result, for example. And yeah, so let's say result, and then we're saying result. And here we can say something like value query set the result as, here you say as paragraph element, which it is, and then here you can say what you want to do. For example, you could say title length. What are we in need of? The value, attributes, client. Actually, it should say value, maybe text, which would be then our feature, our function. Sorry, analyze takes an input string to list, and that would be itself actually. No, sorry, what am I saying? That would be actually this guy here on top. That's not beautiful code right now, just so you know. So let's say text. I'm not quite sure if this works. We have to see. It complains about something. What is it complaining about? One warning. A value type of list can't be. Okay, no, that's true. That's true. We have to do it another way. You know what, guys? We're just going to instead, like, let's see, hello. Let's just see if that works. Then hello. You see it appeared. We're going to do that in another tutorial. I know how to do this, but it's just going to be too long. We would work with diffs and loops just so you know how we're going to solve that. But yeah, I'll see you in the next part of this tutorial then. Bye.